It's lesson 42, and today is the day you've been waiting for, the day you've just been like, why have we not learned this yet? I'm so ready for it. And ClassroomofTigers is going to finally give it to you, right? Here's the idea, right? We're looking at decimals today and solving problems with decimals. And as we look at these problems, what we want to understand is that some decimals, or some numbers, when I divide them together, such as 40 divided by 30, that's not what I want. Let's go 30 divided by 40. That's going to be the right answer. 30 divided by 40 is going to give me an answer of 75 hundredths. And we get kind of a round answer. There's no like decimal forever. There's no remainders. Everything worked out perfectly. We call that a terminating decimal. When everything just, it's set, it's final, there's nothing left over. And while decimals like that are nice, are convenient, we love them, the fact is they don't always come like that, right? Sometimes numbers come in very, very strange looking forms and different ideas, and they seem to repeat. And very often that's exactly what they're doing. And that's where we get our lesson for today, what's known as repeating decimals. When I look at a number such as 43 divided by 6, which would give me an answer of 7 and 1, 6, 6, 6, and the 6's would just continue on forever. And the question would be, well, how do you write that on your paper if it's going on forever, right? Same with this idea here, 3 and 5/10 divided by 11, right? We get a solid 3, but then suddenly we get this 18, this 18. They keep showing up in the exact same pattern, right? And this is what we call what's known as the repretend, all right? Or in layman's terms, non-mathematical, we would call that the repeating decimal. And that's what we want to understand today. How do we take something when we get an answer like this that just seems to keep on going? What do we do with that idea? All right, we turn here. I don't think all my words are showing up on your screen. There we go. So, how do we take a number and turn it into a repeating decimal, right? So, if we get an answer that shows up like this, let's transform this into a repeating decimal. When finding a repeating decimal, we're going to use a really simple symbol. It looks like that. And that little bar means repeat. But you can't just put it over anything you want. It has to be the value that is actually repeating. All right? And so we got to look for that. So let's look at letter A. Letter A says you have 0 and 3, and then of course the 3's go on forever. So how are we going to write that as a repeating decimal? All right, so we're going to put our place values that we must have. We got to have that 0 there, and we know the 3 is there. And now the question is, what is repeating? Is it the 3 repeating? Is there something else? This one, of course, is pretty easy. There's only one number there, and so we would put a bar over it, and we would say that's our repeat bar. And we have that one solved. All right. However, as you look at the next example, you notice that they're not always as nice as letter A. Sometimes they are much more complicated. And so you see the answer here in front of us that might show up on a calculator. You know, if you really took the time, it'd show up in your work as you solve this problem. And suddenly the question is, all right, you're going. About this point, you're ready to kind of just be like, oh man, I don't want to do this on my paper anymore, right? But if you would have stopped there, you would have gotten the wrong answer because you needed to go to about here, possibly even to here, or even here before you really know that the decimal is truly repeating, right? Now, usually by about the third or fourth when it comes up, by that time, you're going to know that it's actually a repeating decimal. But what do we actually put for the repeat then? All right. So the 5 is constant, right? That part is not a part of the repeating decimal. That's not a part of the repetition. I know there's a 5 there. Don't tell me, oh, there's a 5 there. Yeah, but it's not in the same order, right? It goes 5, 7, 1. This isn't 5 if 7, 1 isn't there. All right. So the 5 isn't really a part of it. All right. In fact, in general, we don't even want to look at the whole number. We just want to look at the decimal place value because that's where we can actually repeat things. We can't repeat things before that. All right. So what is the pattern, right? In the end, we would come away saying, okay, I see a 1, 4, 2, 8, 5, 7. Right? A 1, 4, 2, 8, 5, 7. A 1, 4, and we could assume that this is going to be 2, 8, 5, 7. Just like that. So what is our answer going to look like? We're going to put the 5 down, decimal point down. 1, 4, 2, 8, 5, 7. And a bar over all of those place values, all 6 of them. And by putting it over all 6 of them, we're going to get the response that we want. All right. Okay, this one's yours. Take a minute, solve it, think about it, write the repeating decimal. All right. Now, the book wants you to also understand, or math in general, not the book. Math in general wants you to understand that sometimes in math, it's important to, maybe you need to go a few extra place values, even though your repeating decimal isn't going to really allow it, because there's going to be some value in just kind of making it like a terminating decimal and just have a kind of a final answer. So you're not dealing with this repeating number. And in essence, it becomes an estimate of the actual answer. So how does this work? Right, round each number to the 5 decimal place. All right. What does that really mean? It means we want to go 5 decimal places. 1, 2, 3, 4, 5. All right. Well, there's nothing here right now under these ones, but this symbol right here tells us that this should be a 6, and this should be a 6. And so we're going to round to this place value. Well, to round, don't you have to look back one, Mr. Fisher? Yeah, of course you have to look back one. But you know what that one is. It's also a 6 because of that repeating decimal. So in the end, I can say, okay, here's my number, 66. Am I going to round up? Am I going to round down? I'm going to round up. And so in the end, I'm going to get an answer of this, right? How many place values I got? 1, 2, 3, 4, 5. 5 decimal place values, just like the problem asked. And I rounded up to get that answer. All right. Here we go again, right? I want to know my values. I see the 405 repeats, 405 repeats. So I put the 405 down. And now I look here, I'm going to this place value. I'm going to look back, right? So is 5 going to round up or down? It's going to round up to 10. And so the final answer becomes, right? 1, 2, 3, 4, 5. 5 place values, just like the problem asked. From here, we can look at comparing them. I could have done a couple comparisons, but arranging from order of least to greatest also helps us compare things, right? What we need to understand with this number right here is that it doesn't really end right here at this place value, but it's this forever. And so with that in mind, which of these numbers is going to be the least, greatest, etc. Go ahead and solve that problem. And I'll leave you with one more sample problem as you head out working with, first of all, discovering the repeating decimal, and then rounding, in this case, says to the nearest hundredth.